Hi guys, welcome back to another video. Today I'm going to do a quick presentation about Google Colab. So basically, what is Google Colab? It's a cloud-based Jupyter notebook environment provided by Google. It's designed for machine learning, data analysis, and Python coding. And it's basically an executable document that allows you to write, run, and share code within Google Drive. So it's kind of just like a Jupyter notebook stored inside of Google Drive because it has like all the same functions and everything. And it's helpful because there are no local installations required. You get access to GPU and TPU support, and it's really helpful for collaboration and efficiency. So why do we use it? It's free and accessible because it only requires a Google account and it works in any browser. It's also ideal for beginners because they have pre-installed libraries, built-in documentation, and examples. And it's helpful for collaboration because it's shareable with live editing and commenting features. So some key features is that you have code execution in cells, just like Jupyter. It supports Python and Markdown, so you can have code and text cells, which is really helpful for like collaboration. So you can like describe your work. And you can import libraries and connect to data sources. And then you can use GPU and TPU, which accelerates heavy computations. And it's integrated with Google Drive, and there's version control with GitHub. So we're gonna do a quick demo, just like setting it up and using it a little bit. So first, you can just search up Google Colab, and then you can scroll down to this, and then we'll press Open Colab. And so you can open like notebooks if you already have any, or anything from your Google Drive. You can upload something, or this is really helpful. You can enter a GitHub URL here, and it can open something from Git. But we're just for now gonna go to New Notebook, and it's gonna create a new notebook for us. So as you can see, it basically kind of just looks like a Jupyter notebook, and you can you can like just start. Oops, you can start um like just doing anything. And basically it works the same. I press Shift Enter to execute a cell, or you can press this play button, but that's probably a lot harder. And it's basically exactly the same as Jupyter. You can do like anything. And it like, as you can see, it kind of predicts like what you think, what it thinks you're gonna type. So as you can see, it says start coding or generate with AI. If you press that, we can just do what they say, create data frame with 2 columns and 10 rows. And it'll do that for us. Here's like an example data frame. And we can run that, and this is what it gives us. So a few other things, you can like move cells up and down with these buttons on the side. If you hover like to the side, you can delete a cell with with this button here. And you can also do text cells. So if you go up here, there's a code in the text cell. And this basically works the same as Jupyter Markdown. So you can do like a heading here, sample text, whatever. And it's nice because it shows a preview on the side to the right before you like enter. And it's also like you can do math stuff, so it's kind of the same again as Jupyter. You can do something like this is just like a sum function. And then you can see there's a preview on the side. And then it will just show up like that. So this is just helpful because when you're collaborating with people or even just for yourself, you can like write descriptions of your code. And then one more thing is that if you go over to the right bottom corner, there's like these two arrows and it's called code snippets. And they just have like examples of like codes of like a lot of different things. And let's just do like a visualization. I'm gonna choose the first one, histogram and Altair. If you press the plus button, it should show like a preview on the bottom, and you can press insert right here. It will just show it here. So you can see the loaded example data set, which is you can see about cars. And then they just plotted a histogram here. And if you run it, here's the result. So you can just like take a look at those things and then you can just they can just be helpful to learn from. So another important thing is like importing files. One way to do it, you can upload files. So you go from Google.colab, import files, and then upload it files.upload. And then it will say choose files, and then you can choose any file that you want to upload here. But I'm not gonna do that. Or you can do from Google. So now we're gonna, okay, I guess everybody knows, but we're just gonna allow Google to import things from our Google Drive. And so we run that and it'll say, permit this notebook to access your Google Drive files. I'm gonna say yes. And I'm gonna choose an account and then just allow it access to my Google Drive. And from then we can actually like import files from our Google Drive. So I'm a import a CSV file from um, a folder called Google underscore collab. I'm gonna do the example.csv. So I'm gonna just do, well, first I'm gonna import some stuff real quick. Okay, but I'm gonna do df equals pd, same as read that, same as like you would just do in pandas. I'm gonna do content slash drive like we did before, my drive slash, and then the file path, Google underscore collab, and then mine is called example.csv. And then I'm gonna just do print bf.head 5 to print the first 5 rows of the data frame. And so this is what it is. Um, and just as an example, I'm gonna just plot a histogram of, I'm gonna choose the column credits, and it will just show like a histogram of like the average amount of credits people take, or not the average, but just like a count of the amount of credits that people are taking this quarter in this class. Okay. And one more thing that's important is just that like sharing the notebook. So you can go up here and share. And this is like just like the same as how you would share any Google document. Or you can go to file and then you can say save a copy in GitHub, which is pretty helpful. But for me, I I used share link for our next demo. So I'm gonna just do that right now as well. So basically now we're gonna do a TensorFlow demo. And so with the share link feature, I created a link. I put it in this slide so you can find it there, or probably in the description too. This is just a link to a notebook for our demo. But before we get into that, um, you may be wondering what is TensorFlow? And so basically, it's an open source machine learning framework developed by Google. It enables building and training machine learning and deep learning models. It supports computations on CPUs, GPUs, and TPUs, and it provides a flexible, scalable, and efficient ecosystem for machine learning. And so it's commonly used for things like image and speech recognition, natural language processing, recommendation systems, predictive analytics, and other things like that. And we're also going to be using Caris, which is an API as a part of TensorFlow, and it helps with building and training deep learning models. It's user-friendly because it has very intuitive syntax, as you will see, and it has pre-built layers, loss functions, optimizers, and metrics. It is designed for fast experimentation and prototyping, and it simplifies common tasks like building neural networks and handling data sets, which we will also do. And so why do we use them for TensorFlow? It's highly optimized for large scale computations. It's actually an industry standard for machine learning and AI research, and it's very versatile for advanced applications. And for Keras, it reduces boilerplate, like very like repetitive code, and it makes development faster and simpler. It encourages modular design for building complex models layer by layer, and it integrates really well with TensorFlow. So if we open this notebook that I shared, first we're going to import TensorFlow, and then we're going to print the version. And then if you don't have it installed already, you can do a pip install TensorFlow. Above, you can uncomment that. So basically, we're going to enable GPU acceleration through runtime settings. So right now, we're usually going to be using a CPU because GPUs are like much faster and are good for tasks that are very complex, like for running neural networks. And usually, if you're not doing that, you can just use a CPU. But we're going to go to runtime at the top. We're going to we're going to select change runtime type, and then we're going to select the GPU, and you can click save. And so you'll see that like over here, it would say um, connecting, and it should say connected. But yeah. But now we want to verify that the GPU is available for computations. So we're just going to print this cell, and then this command will just show which GPUs are available, and it will show over here. And then, so what we're going to do is we're just going to create a simple neural network model using Keras. And this is basically just to show like how simple it is to do such a complex task through Keras. So the one we're going to make, it's going to be a simple feed-forward neural network with 3 layers. So for the 3 layers, we have the input, the hidden, and the output layers. For our input layer, you can see that it accepts 10 features as input. For the hidden layer, there's 2 layers with 64 and 32 neurons. It uses a ReLU or a rectifier activation function, and the output is a single neuron with a sigmoid activation function, and it predicts binary outcomes. And then we'll compile the model using .compile. And then you can see our optimizer is Atom, our loss function is binary cross entropy, and the evaluation metric is accuracy. You can see it's like everything's just like written out super straightforward, and you can see exactly what you're doing. And then we're going to do .summary to print a model summary to see the architecture. You can see like after we print the summary, it shows everything right here. And then we're also going to generate dummy data with NumPy. So we're going to create a random input data xtrain and xtest with 10 features each and generate random binary labels, ytrain and ytest for training and testing. And then this can just allow us to experiment with the model setup without needing a real data set. So we just do np.random for each and specify like the size. Okay. And then we will train the model, and we're going to use the .fit method. So we're going to train for 10 epochs, which is just like 10 training cycles. with a batch size of 32. And during training, the model will adjust its weights to minimize the loss function and improve accuracy. And we also include validation data, X test and Y test to monitor the model's performance on unseen data. So you can see it shows each of the cycles, and it shows the accuracy and the loss, and the validation accuracy and loss. And then we can evaluate the model using .evaluate, and this provides metrics like loss and accuracy on unseen data, which helps us understand how well the model is generating. You can see the test loss and the test accuracy is given. And then we can also save our model and we can reload it later. So basically, we're going to save it to mymodel.caris and then reload it using the load model function. And this helps us so that our work isn't lost and we can reuse the trained model later without retraining. And this is helpful for deploying models and sharing with others. So we'll do model.save and then name it to a file. And then we can reload it by importing load model and then reloading it. And then lastly, we're just going to visualize the training results by using matplotlib. And then we just plotted the accuracy and the loss. But yeah, that's all about Google Colab. It's very useful for any project. I feel like it's not really used very often, but can be super helpful for collaborating. And it's a really good resource. But yeah, hopefully this helps. And thank you for watching.